You have a Docker image. It runs perfectly on your laptop. Now somebody needs it running in production. Always on, surviving crashes, behind a load balancer, scaling when traffic spikes, and not costing a fortune at 3 in the morning when nobody is using it. Kubernetes can do that, but Kubernetes is a lot, and a surprising number of teams do not need all of it. AWS has its own answer, and it is genuinely simpler: Elastic Container Service. In about 12 minutes we take ECS apart. One example the whole way through: a Node API and a background worker, both containerized, going to production on AWS. By the end you will know its object model, both launch types, how it networks, how it scales, and, crucially, the one real reason not to use it. Start with what is actually missing. A Docker image is a frozen file system plus a command. Docker run starts it. That is genuinely all Docker gives you. So think about what production actually demands. The process crashes at 2 in the morning. Who restarts it? You want 3 copies for redundancy. Who places them on different machines, and who notices when one machine dies? You are deploying version 2. Who brings up the new containers, waits for them to pass health checks, drains traffic from the old ones, and rolls back if the new ones are unhealthy? Traffic triples on Black Friday. Who adds more copies, and who takes them away afterwards? Every one of those questions is about the gap between a container and a service. Filling that gap is what a container orchestrator does. ECS is AWS's orchestrator, and unlike Kubernetes, it was designed from day one to lean on the AWS services you already have. Concept 1. What ECS actually is, and what it deliberately is not. ECS is a container orchestrator built by AWS for AWS, and the important word there is for. It is not a general-purpose platform that happens to run on AWS. It is a control plane that assumes IAM is your permission system, that CloudWatch is your logs, that an application load balancer is your ingress, and that a VPC is your network. It does not implement any of those, and that is the whole design philosophy. The consequence is that there is dramatically less to learn, because you already know most of it. There is also, and this is the part people forget, no control plane to run and no control plane to pay for. The ECS control plane is free, fully managed, and invisible. You do not patch it, you do not upgrade it, you do not get paged by it. The trade-off is that ECS runs only on AWS. Which brings us to the honest framing. ECS is what you use when you have decided AWS is your platform and you want the shortest path from a container to a running service. Concept 2. 4 nouns. Learn these and ECS stops being confusing. There are exactly 4 things in ECS and they nest. A task definition is a blueprint. It is a JSON document that says, run this image with this much CPU and memory with these environment variables with this IAM role, sending logs here. It is a template. Nothing is running. A task is one running instance of that blueprint. One or more containers actually running right now. If it crashes, that task is gone. Tasks are disposable and you should treat them that way. A service is the thing that keeps tasks alive. You tell a service, I want 3 copies of this task definition, always. It launches 3. One dies, it launches a replacement. You deploy a new version. It does a rolling replacement. The service is where all the durability lives, and a cluster is just a logical grouping. A namespace, a bucket to put services in. Blueprint, running copy, the thing that keeps copies running, and a folder. That is the entire object model. Compare that to Kubernetes, which has pods, replica sets, deployments, services, ingresses, config maps, and namespaces before you have done anything at all. Concept 3. The blueprint in detail, including the 2 IAM roles people always confuse. Open a task definition and here is what is inside. Container definitions, usually 1, sometimes 2 if you have a sidecar. Each names an image, a port to expose, environment variables, secrets pulled from secrets manager or parameter store, and a log configuration pointing at CloudWatch. Then CPU and memory. And here is the first real gotcha. On Fargate you must declare CPU and memory at the task level, and only certain combinations are legal. You cannot ask for a quarter of a vCPU and 30 gigabytes of RAM. There is a table, and you will meet it. Then 2 IAM roles, and everybody mixes these up. So let us be precise. The task execution role is used by the ECS agent before your container starts to pull the image from ECR and to fetch your secrets. The task role is assumed by your application code at runtime, when it calls the AWS SDK to write to S3 or read from DynamoDB. Execution role is for getting the container running. Task role is for what the container does once it is running. Two different actors, two different roles. And finally, task definitions are immutable and versioned. You never edit one. You register a new revision and you point the service at it. That versioning is what makes rollback a single API call. Concept 4. The launch type, the biggest decision you make in ECS. ECS gives you two ways to actually get compute underneath your tasks, and they are radically different. EC2 launch type. You run a fleet of EC2 instances, each with the ECS agent installed, registered into your cluster. ECS schedules tasks onto them, packing multiple tasks per instance. You own those instances. You patch them, you scale them, you pay for them whether or not they are running anything. In exchange, you get cheaper compute per unit, especially with spot instances or savings plans, plus GPUs, plus the ability to bin pack tightly. Fargate launch type. There are no instances. You hand AWS a task definition and AWS runs it. You never see a server, never patch one, never scale one. You pay per vCPU second and per gigabyte second, only while the task is running. It is more expensive per unit of compute, meaningfully so, and you give up GPU support and some low-level control. The honest guidance, default to Fargate. The premium you pay is almost always less than the engineer hours you would spend running a node fleet. Move to EC2 when your bill is large enough that the maths flips, or when you need something Fargate does not offer. And note this before we get to EKS, Fargate is not an ECS feature. It is a compute engine, and EKS can use it too. Concept 5. The service, where self-healing and zero downtime deploys actually happen. A service holds one number that does all the work, desired count. You say 3. ECS's job, forever, is to make running count equal desired count. A task crashes, running count drops to 2, ECS starts another. An availability zone fails, ECS starts replacement in a surviving zone. You never restart anything by hand. You change a number, or you change nothing and let it heal. Now deployments. The default is a rolling update, controlled by two percentages. Minimum healthy percent. How far below desired count ECS may dip during a deploy. Maximum percent. How far above? Set minimum to 100 and maximum to 200, and ECS will bring up 3 new tasks alongside the 3 old ones. Wait for the new ones to pass their load balancer health checks, then drain and kill the old ones. Zero downtime, at the cost of briefly paying for double. If you need something stronger, ECS integrates with code deploy for true blue-green, where the new version gets its own target group and you flip traffic in one move, and can flip it back instantly. The interview point. Your health check is your deployment safety net. If the health check just returns 200 OK without actually checking your database connection, ECS will happily roll out a completely broken version and report success. Concept 6. AWsvpc mode, where ECS gets seriously elegant and seriously constrained. In AWsvpc network mode, which is mandatory on Fargate and strongly recommended everywhere else, every single task gets its own elastic network interface with its own private IP address in your VPC. Think about what that gives you. Your task is a first-class citizen of the VPC. You attach security groups directly to it, so you can write a rule that says, the database security group accepts traffic on port 5432 only from the worker task's security group, not from an IP range, not from a whole subnet. From that workload, flow logs work, VPC and points work. Everything you learned about VPCs applies and changed. It is genuinely the cleanest container networking model any orchestrator offers, and it has a cost which is the same cost EKS pays and which you should be ready to name in an interview. Every task consumes a real IP address from your subnet. A /24 subnet has 251 usable addresses. Run 300 tasks and you have run out of network before you have run out of CPU. Plan your sitter blocks with your task count in mind, not your instance count. Concept 7. Getting traffic in and letting services find each other. For inbound traffic, ECS does not invent anything. It uses an application load balancer, the same one you would put in front of EC2. You associate a service with a target group, and here is the good part. ECS registers and deregisters tasks in that target group automatically as they come and go. A new task passes its health check. ECS adds it to the target group. Traffic flows. A task is being replaced during a deploy. ECS deregisters it. The ALB drains in-flight connections, and only then does the task get killed. You wire it up once and never think about it again. For service-to-service traffic, your API calling your worker, you do not want to go out through a load balancer. That is what ECS Service Connect and before a cloud map is for. It gives each service a stable DNS name inside the cluster, so your API just resolves worker.internal and gets a healthy task. Service Connect is the newer one, and it adds a proxy sidecar, which buys you retries, connection reuse, and per-service traffic metrics without you writing any of that. If someone asks how services find each other in ECS, that is the answer. Concept 8. 2 layers of scaling, and people constantly forget the second one. There are 2 independent scaling problems, and confusing them is a classic interview trip up. Layer 1 is service auto-scaling. How many tasks? You attach a target tracking policy, keep average CPU at 60%, or keep requests per target at 1,000, and ECS adds and removes tasks to hit that target. This is the layer everyone remembers. Layer 2 is capacity. Is there anywhere to actually put the new tasks? On Fargate, this layer does not exist. AWS always has room. Scaling tasks is the only node and you are done. On EC2 launch type, it absolutely exists. And if your instances are full, ECS will try to place a new task, fail, and the task will sit in pending forever while you wonder why scaling did not work. The fix is a capacity provider with managed scaling, which watches for tasks that cannot be placed and grows the EC2 auto-scaling group to make room. So, Fargate, 1 layer, EC2, 2 layers, and you must configure both. That single sentence answers a very common question. Concept 9. When ECS is the right call, and the one honest reason to walk away. Use ECS when you are all in on AWS. When your team is small enough that a dedicated platform engineer is a luxury you do not have, and when you want to go from a Docker file to a production service this week rather than this quarter. The wins are real. No control plane to run or pay for, an object model you can learn over lunch, IAM and CloudWatch and ALBs that already work the way you expect, and Fargate meaning you may never touch a server again. Mouth the catch and say this out loud in an interview because it is the honest answer. ECS runs on AWS and nowhere else. Your task definitions, your services, your capacity providers, none of that moves. If you later need to run in another cloud, or on-premises, or you get acquired by a Google Cloud shop, you rewrite your orchestration layer. Now, how much does that actually matter? Less than people claim. Your Docker images are portable regardless, and most companies never leave their cloud. But the honest position is, it is a real trade. You should make it deliberately, and if you already have Kubernetes expertise on the team or a genuine multi-cloud requirement, that trade goes the other way, which is exactly the conversation we are going to have in the ECS episode. Let's put it back together. ECS is AWS's own orchestrator, built to lean on IAM, CloudWatch, ALBs, and your VPC rather than reinvent them, and its control plane is free. 4 nouns. A task definition is the blueprint. A task is a running copy. A service keeps the right number of copies alive, and a cluster is a folder. Task definitions are immutable and versioned, and they carry 2 different IAM roles. The execution role pulls the image. The task role is what your code uses. 2 launch types, Fargate, where you never see a server, and EC2, where you do and it is cheaper at scale. Default to Fargate. Every task gets its own ENI and its own security group, which is beautiful, and which eats a real VPC IP addresses, so playing your sitter. Scaling has 2 layers, and on EC2 you must configure both or your tasks sit in pending, and the one honest cost is lock-in. Next up, X, and then the episode where we settle which of the 2 you should actually pick. Subscribe!